Hi guys, welcome to Code and today we are going to discuss a problem called Subarray sum equals k. It's a medium level question in LeetCode, and let's read the question. So what question states is they are given an array of integer nums and integer k. Return the total number of contiguous subarray whose sum equals to k. So basically what they're asking is, let's see the example one. So they have given a nums, right? 1, 1, 1. And we have to find the subarray which has a sum of 2. So, sorry, the number of subarray. So here we can see two subarrays. How 1 plus 1 gives to 2 and 1 plus 1, right? If you didn't get it, let me just explain you clearly. Uh, so basically, this is one set, this one subarray, right? And this is one subarray, right? So this is the first subarray and this is the second subarray. So totally two subarrays are present in this example that contributes to sum of two, right? Get it? So for let's take some other example. Let's take 1, 2, 3, right? And the target is 3. So, how many number of subarrays can you find which contributes the sum of 3? So, in this, we can see that these two contributes the sum of 3 and this alone contributes the sum of 3, right? So, totally there are two number of subarrays, right? So, the answer will be 3. I guess you get the idea, right? So, how can we do this? Basically, you can do this using a lot of ways. One of the naive approach will be just iterating it. That is, using. I mean, oh, we take two for loops and just iterate it, and at the same time check if the sum is equal to the k, right? So that's one of the brute force approach, which gives a time complexity of n square. But the question is, and space complexity as well. So the thing is, can you reduce it? Yes, of course you can reduce it. So what can we do? So basically, we are uh, taking a help of something sort of like a prefix sum, but not exactly prefix sum. Basically, for this method, you don't prefix sum also, but we are using that concept, but using only one variable, that is using sum. We are also taking care of the space complexity. Uh, Also, you can use a prefix array and just add it so that if you for example, if you take this example, it is 1, 1, 1. What will be the prefix sum of this? What is this index? 0, 1, 2, right? So what will be the prefix sum? Prefix sum will be 1, 2, and 3, right? This is the prefix sum, right? So in this, can you find out what are the um, uh, value? I mean, if you want to find k value 2, you can easily find it out. That is, this is this one, and 3 minus 2, that is 3 minus 1, that is this one, right? You can do this using a pointers, but even that takes a uh, uh, I mean pretty more complexity, like even that takes n square. But you can, instead of iterating it, you can store it permanently so that you don't repeatedly search for the same element. For that, we are using a hash map. So basically what we are doing, why we are taking hash map is, let me just explain. So in this uh, we have seen that the prefix sum will be 1, 2 and 3, right? So basically we'll take a hash map. Let's take a hash map. This will be a key and this will be a value, right? So what we do is we just iterate. So uh, we will our pointer will be here. So this is 1. Is 1 equal to 1 equal to k? No, it's not equal to k. And we'll also check if the sum, we are just adding, right? As I said, we are not taking a array, prefix array. We are not storing this, right? So basically what we are doing is we are just taking a single variable sum and calculating its sum, right? So when sum equal to 1, that is we push the 1 inside this, we check it with k. Is this equal? No, it's not equal. And we also check if sum minus k is present in the map or not. This is sort of a same method which we used in the previous question which I have uploaded in the channel. Do check that out. That is pretty much very similar to that question. So basically we check if sum minus k is present in the array or not. Why sum minus k? It's pretty much logical, right? Why? If we are finding something like sum minus, for example, if you want to get the here the sum is 2, right? Just see this, just watch carefully. To find this sum equal to 2, what we do, we just subtract, usually subtract 3 minus 1, right? If 3 minus 2 1, if you are getting the output as 2, then we are printing, we are just counting this as a valid one, right? So basically what we are doing, this is sum minus the num, right? Num of I, right? So the specified num, if you are minusing this, we get the k value. We are doing the pretty much the same thing. So that is sum minus nums of something which we are finding equal to k. But instead of doing this, what we are doing is we want to find this one. We want to find the num where this num is, right, in the map. So what we do is we just interchange saying sum minus k equal to num, right? We are just interchanging it. So we are finding this once. If we get this value, we get this value, right? It's pretty obvious. So we are storing these values in the map so that it will be easy for us to just figure out if the num is present or not, or else we have to iterate once again, right? So in that place, hash map really helps us a lot. So now let's see the implementation. So basically what we are doing, so we check this, we see the sum is not equal to k, then and we also see if sum minus k, that is 1 minus 2, that is minus 1, is present or not. It's not present. Okay, it's not present. So just push this element into the map and say this count is 1, right? We only found this element once, right? So count is 1. So next to, right? So we check if sum is double equal to k, that is 2 equal to 2. Yes, it is present. The sum is true, so we increase the count. uh, Earlier it will be 0, now we increase the count by 1, right? We found the element. So again, okay, we found the element, just push this into the map and say it is visible, it has been seen only once, right? Cool. Now we push 3. So we push 3 and sorry, we push 3 and sum equal to 3. 3 is not equal to 2. No, it's not equal to 2. And is 3 minus 2 sorry, 3 minus k, that is 1, is it available in our map? Is it seen in our map? Yes, it is seen. It is seen, right? So we just if it is seen, we just increase the count of it. And also we say it is, we increase this count also because we have seen that element earlier in the map, it is visited, and we also push 3 in it, and we have reached the end of the loop. We just display the count of it. I hope you have understood. If not, let me just code it out so that it will be clear. So this is a code. So basically we are taking, as I said, we are taking a map, and instead of sum you can also take a array which calculates the prefix sum. But if you are taking just a sum, it is more optimized because space complexity will be saved. So first, as I said, we will check if sum is double equal to k. If it is equal to k, just increase the count, or else we find if that sum minus k is already present in the map or not. If it is present, we just increase the count, and also we add the sum which is seen into the map, saying that it's already seen, right? As we seen here. I guess I have erased it. Okay, it's fine, but you have seen it, right? So yeah, like so that we can it will be helpful for the next iteration if the element is visible or not. So yeah, just return the count. So let's run this. It does work. It does run. So yeah, that is pretty much it from this video. If you like the approach, to like the video, and there are a lot of videos which have been left from this channel, to check that out too. Thanks for watching this video. Do subscribe to our channel. Bye. Thank you.